Welcome to homework.
Question 38 asks us to verify the proton-proton cycle energy release. So the proton-proton cycle is essentially how the sun creates its own energy, starting from hydrogen. From two hydrogen atoms, we create helium-4, along with those two initial hydrogen atoms, and the cycle continues. So these are the equations that describe it. The values in parentheses on the right-hand side here are, as told in the textbook, the amount of energy that's produced from each reaction. And the final column here is how many times this process occurs in the proton-proton cycle. So our goal for this question is to verify that this is the amount of energy that's produced in each of these interactions. And if we add all the energies in this format, then we should get what's the expected total energy value of 26.7 MeV. So that's our goal. And the way we'll do that is if we know that the amount of energy that can be released from a reaction is just based on the change in mass times c squared. So we'll use this equation for each of these processes, see if it matches the verified value, and go from there. So one thing we need to do when we're going through this type of problem is that while it tells us masses of hydrogens and heliums, etc., we need to consider the mass of the nuclei, rather than the atom itself. So we need to exclude the mass of electrons. Sorry for my poor writing, but we'll see how that goes. So for equation 1, we have hydrogen on the left-hand side. So for each of these, I'm just going to look at the change in mass, and then I'll perform the equation afterward. So we have the mass of hydrogen plus the mass of hydrogen. That's on the left-hand side. And again, we're told to exclude the mass of the electrons. So you subtract off 2 times the mass of an electron, we'll say. I subtract whatever is my final products. Which here it's a deuterium. So I'm going to say mass, go capital D for deuterium. Subtracting off the mass of a positron, which is the same as the mass of an electron. So minus the mass of an electron. The neutrino has no mass, so we don't need to consider that. And for the deuterium has 1 electron as well, so I'm going to subtract off 1 electron from the deuterium. So looking at this, I can actually simplify this a bit. So I have a negative. So if I put this as positive, make this a positive, then I have a negative deuterium mass here. However, I have 2 positive masses of electrons minus 2 electrons, so the mass of the electrons here entirely cancels out. So I have the mass, 2 times the mass, actually let's rewrite this out so it's very clear. So 2 times the mass of hydrogen minus the mass of deuterium, which these values are easily determined, easy to look up, so I'm just going to give the final value in terms of atomic mass units to be 4.5 times 10 to the negative 4U. So that's my mass defect for equation 1. And again, we'll look at the energies afterward. So for equation 2, I have deuterium, hydrogen, and then a helium-3. Gamma has no mass, so I don't need to consider that. So for equation 2, on my left-hand side, I have mass of deuterium plus the mass of hydrogen. Each of these have 1 electron, so I can subtract off the mass of 2 electrons. I subtract off my right-hand side, mass of helium-3, so I'll go mass, I'll say He3, which also has 2 electrons. And again, I don't need to consider the gamma ray. So I have a negative and a negative here, so these 2 masses of my electrons cancels out as well. This one's a bit more clear, so I won't rewrite it, but it says mass of deuterium plus mass of hydrogen minus mass of helium-3. And that mass difference is 0.005898U. So again, I would verify each of these just to double check where I'm getting these values from, but I am just looking up the values for the atomic mass values, I should say, for each of these elements that I'm showing. And finally, for equation 3, I have two helium-3s, so I have 2 times the mass of helium-3 here. And I subtract, and then I should consider each of these have 2 electrons. So I'm going to subtract off 4 times the mass of an electron. And subtracting on my right-hand side, which is helium-4, mass of helium-4. So this should be plus. Yep, okay. And so, and then I have 2 mass of hydrogens, so I add 2 times the mass of hydrogen. I think my helium-4 has 2 electrons. I have 2 electrons from each of these, so I have, again, 4 electrons. So I subtract off the mass of 4 electrons. And I don't know, looking back, I don't know why I did put a plus there. It should be minus because I'm subtracting off. And I have a minus and negative, so these massive electrons cancels out as well. So in this equation, I have 2 times the mass of helium-3 minus the mass of helium-4 and overall minus mass of hydrogen. And again, looking this up, you can calculate on your own. You'd find that this mass difference is 0.0138 U. And so again, looking at the energy of each of these equations, I have my delta mass times c squared. If I want to convert these atomic mass units into energy, I take my value and multiply it by the energy to mass conversion factor of 931.5 MeV per U per c squared and multiply that by c squared. So I'll use this equation to solve for the energy in each state. For equation 1, the energy is, 0. Oh no, it is exactly what was given. Sorry, so it is 0.42 MeV. In 2, I do calculate, again, I'm listing the same values that are shown above, but these are the actual values that I am calculating. 5.49 MeV. And for 3, the energy, literally this is 1, 2, and 3. This is 12.86 MeV. So the energies of each of my states. One thing I also need to consider, I'm going to write it down and then I'll state what it is, why. In stage 1, there's a creation of, up here, creation of a positron. So after the positron is created, it releases 2 high energy photons with energy of 1.022 MeV. So that needs to be considered in this proton-proton cycle, that this is an additional creation of our products of round 1. So I can say that the total energy of this proton-proton cycle, considering everything that's provided here, so I have 2 times energy of round 1 plus 2 times the energy of round 2 plus 1 times the energy of round 3 plus the energy produced from the positron. And if we were to calculate this up, and I'll do it on my own just to verify, I get, again, exactly what is told to us, that the energy of the cycle is 26.7 MeV. So there you go.